So hello, today I will discuss moment of forces. So now let's define what is moment of force. So moment of force is nothing but a kind of torque which is produced by the force to rotate the body or a massive object about a given axis. And if we talk about the magnitude of this moment, then this will measure the strength of the torque that is essential to rotate a body or which is useful for the rotational motion of a body or a massive object about a given point or a axis passing through a given point. Okay, so now let's understand what is the torque or what is the moment of a force. So let's consider a simple example. This is nothing but a car wheel, or we can say it is wheel of a two-wheeler or three-wheeler or four-wheeler, doesn't matter, and the force is acting at this point on this wheel in this direction. So let's say this is the x direction and this is the y direction, and this is the center of the wheel, point O here. Okay, now we can estimate, we can measure the moment of this force. So for estimating the moment, if I extend or if I draw the line of action of this force and then the line passing through the center, and if I draw a perpendicular from this axis to the line of action of force, and this distance is the perpendicular, then we can define the moment of this force. So the moment of force M about point A O is the magnitude of force multiply perpendicular distance from point O or the line passing through this point O to the line of action of this force. Okay, so we can write in simplified form, the moment about point A is the magnitude of the force F, and D is the perpendicular distance from the force to point O. Okay, so now we can write here that the moment of force about a point or axis passing through a point is equal to magnitude of force times perpendicular distance of F from point or axis about which we need to calculate the moment of force. Okay, so this is the simple mathematical formulation, and then if you can also write this expression in the words. So the moment of force about a point or the axis passing through a point is equal to the magnitude of the force times perpendicular distance of F from the point or axis about which we need to calculate the moment of force. Now if d equal to 0, then the moment of force will be 0. So this is the case. So suppose this is point O and this is the force F passing through this point. Okay, if you want to measure, so force passing through point, then d equal to 0. So the moment about the point of this force will be 0. Or second case can be, so now this is the point and let's say this is the now so this is point and let's say this is the force is here and this is the point O here. Okay, then if you want to measure the moment of force about this axis or about this point O, so in this case M O equal to 0 because d equal to 0. Okay, so when the line of action, this line of action of this force intersect the line passing through this point over here. Okay, in this case the line of action of the force and the axis passing through the point O both are on the same line. Okay, in the both cases the moment of any force will be 0. It means this force will not produce any kind of the torque or any kind of a moment to rotate the object. So as we know that, okay, as we know that the force is a vector quantity It means we write the force, and this is the magnitude. Okay, this is magnitude, and this is the direction of the force. And so if the force is in this direction, then we write the positive force, and the force is in this direction, then we use the negative sign convention. Okay, so this is the sign convention for a force. Similar to the force, moment of force has magnitude and its direction. So therefore we need to represent the moment of force as a vector quantity, or we need to use a signing convention for the calculation. So now let's say this is the body, and this force is acting in this direction, and if you want to measure, this is the point A. Okay, and the same case, second case, same body. Now if I change the direction of the force, and the point is here, this is the point A here. Okay, so now moment of this is the distance d, this is the same distance d here. Okay, so in this case the magnitude of the moment is force into d, and in this case magnitude of the moment is force into distance, perpendicular distance. So now for the sign convention, so this is the point about which we need to find the moment of this force. So this force has a tendency to rotate the body in this direction, and this force, this is the point, reference point. So this force has tendency to rotate the body about this point in this direction. Okay, so this is the, so both forces have different tendencies to rotate this body in this plane. So in this case, so we use sign for this is nothing but the clockwise. This force, we rotate body in clockwise direction, so we use for the clockwise the negative sign, and this force or this moment will rotate the body in anti-clockwise direction. Okay, so this is anti-clockwise direction, and for the anti-clockwise direction we use the positive sign to represent the moment of forces. Okay, so in this case if I write here, so m will be negative value of F into D, and for this case m is positive F into D, or sometime we write F into D magnitude, and then here with the sign convention, and m equal to F into D, and this is the representation of the direction of. Okay, so this is the representation of the direction of moment of the forces. So whenever we need to add the moment of forces, then we have to consider the sign convention. Okay, so always keep in mind that what is the tendency of that moment to rotate the body. If the force has the tendency to rotate the body in clockwise, then we will use the negative sign, and if the moment of the force has tendency to rotate the body in anti-clockwise direction, then we will use the positive sign. Okay, so with these sign convention, okay, so with these convention we can add moments. We can add moments. Okay, so with this sign convention we can add moments as a scalar with proper sign convention. Okay, so this should be clear. So now I take one example. Okay, so let's consider one example. So if I have an object, linear object, and this is the point O here. Okay, this is point O here, end point is O, and one force is acting at this point of magnitude 40 Newton. One force is acting at 2 meter away, magnitude is 20 Newton, and one force is acting at second end on this direction. This is 30 Newton. Okay, so distance is 4 meter. Okay, so this is body. Now so what is the total moment acting on this object? Okay, so net moment So now we have three forces. So net moment about point O. Okay, now we have to find what is the net moment of all forces about point O. So the moment m1, moment of this force 40 newtons force into distance from this line is 0. Okay, so the moment of this force is 0. Moment 2, moment of this force 20 newton, magnitude is 20, and distance between the line of action of this force and line passing through this point O. Okay, so 2 meter. So this is the 40 Newton meter. And then this, now we can use the sign convention. Okay, so this, the line of action of this force is here. So this force has tendency to rotate this object in this direction. Okay, so this is the clockwise. Clockwise means we can use the 40 Newton meter. So m2 is the negative sign. And now m3, moment of this force 30 Newton. So the line of action of this force is here, and the perpendicular distance between the line of action and line passing through the point O is 6 meter. So magnitude of the force is the 30 and distance is the 6 meter, perpendicular distance 6 meter. Okay, so this is Newton meter. So 180 Newton meter. And now what is the sign? So this force has tendency to rotate this object in this direction, means anti-clockwise. Okay, so tendency of this moment, this force to rotate the body in this direction. Okay, so this is the anti-clockwise. Or we can write 180 plus Newton meter. Okay, so now the net moment about point A is the simple algebraic sum of all the moments of forces. So 0, and this is the clockwise, that's why for the sign convention is the 40. This is the anti-clockwise, so if we use the sign convention, this is 180. Okay, so okay, so this is the 180. So 140 Newton meter, and this positive value. Okay, so 1 Newton meter, and then we can write the direction is the anti-clockwise. Okay, so this is the moment of forces acting on this object. Now we can use the concept of moment to solve one problem. So now consider one example. So we have, okay, so this is the ground earth, and then one rod is fixed here. The length of rod is 3 meter. Okay, this is one solid bar, and this is fixed at this point here. So and this angle of this rod with ground is 60 degree. Okay, so now let's say one force is acting here, and magnitude of this force is 75 Newton. Then what is the magnitude of the moment of this force? About 0.0. Okay, so now we can find the moment MO equal to force into D perpendicular. So now this is the force. So okay, this is the force. So this is the line of action, and this is the point O. Okay, so now there are two possibilities. So this distance, let's say we are writing the D perpendicular. So this is the right triangle. So we can estimate the what is the D perp here. So we use the triangle law. And then cos 60 equal to D perpendicular by 3 meter. Okay, so D perp equal to 3 into cos 60, or we can say 3 into 1 by 2, 3 by 2. Okay, so this is the D perpendicular, 3 by 2. So M naught equal to F into 3 by 2, or F is 75 into 3 by 2. Okay, so the 75 into this is 1.5 is around 112.5 Newton meter, and then this force has the tendency to rotate the body in this direction. Okay, so it's anti-clockwise. Now if we consider there are two lines passing through the point O, this one and this one. So if I consider this line, okay, and then this force is here, so this there is a cross section of this force with this the axis. Okay, so the line of axis meets the same line here, it means it intersect. Okay, so the moment of the force about this axis is 0. Okay, only we will get the finite moment of force about this axis. Okay, so there are many examples, so I will discuss later the more examples.